Hi, Assalamualaikum warahmatullahi wabarakatuh. This chapter is all about the applications of differentiation, and it is organized into four main sections here. The first one here will be the introduction to examples of rates of change in problems related to physics, thermodynamics, economics, and medical. And here will be examples of related rates where you have to compute the rate of change of one quantity in terms of the rate of change of another quantity. Now, the third section will be about visualizing the effect of derivatives on a graph, and you will be looking at the local maximum point, the local minimum point, and point of inflection. Also, the idea of concavity and identifying the interval where the function is increasing or decreasing. And finally, we'll be looking at some problems related to maximizing and minimizing a given function. And these problems are also known as optimization problems. Okay, so in particular, this video is just about the introduction to the idea of rate of change. And actually, this idea has already been explained in chapter 2 and chapter 3, but we're just going to revisit and emphasize the idea once again, okay? All right, so recall that if you have this function, y is equal to fx, then the derivative, which is dy dx, is interpreted as the rate of change of variable y with respect to variable x. And this interpretation is already given in the last part of chapter 2. Now note that sometimes dy dx is mathematically described using this notation here. So dy dx is equal to this expression. I'm just going to explain what this expression is all about, okay? So first of all, when you talk about delta y, so delta y is just a symbol to denote that you are taking or you are considering the difference between x2 and x1. So in other words, this is the change, delta x is the change in x when x is equal to x2 and x is equal to x1. Now this value here, x2 can be substituted into the function. So you will get fx2, yeah. x1 can also be substituted into the function, and you will get fx1. So here are the values of y, if you like. So here are the values of y, and so if you take the difference between these two values here, you are talking about the change in y. So the change in y can be denoted using a mathematical symbol such as delta y given here. Okay, so this is delta y, which corresponds to this part, and delta x here corresponds to this part. Now, if you notice, next to this expression here, we have this term, which is limit delta x approaches 0. So in other words, you want to know what's the behavior of this when delta x approaches 0. So delta x approaches 0, in other words, means the change in x, which is x2 minus x1, gets closer and closer to 0, which means that x2 minus x1, yeah, which means that the interval here gets smaller and smaller. So x2 minus x1 will give you some sort of interval, and the interval here is going to get smaller and smaller, and eventually it's going to be very close to 0. Okay, it's going to be very close to 0. So that's the idea. Okay, so here is something that might look similar, but actually there are two different ideas. Okay, so now these two expressions here are different in terms of interpretation, and you will see the difference between these two expressions here in the next example, example 4.1. But before we go to that example, let me just explain to you what's the definition of this expression given here. So whenever you see delta y over delta x, basically the expression or the meaning of it is just average rate of change of variable y with respect to x. So WRT here is with respect to, so that's the short form that I usually use. Alright, so delta y over delta x is average rate of change of y with respect to x. Now, how about this expression here? So this expression here means the instantaneous rate of change of y with respect to x. So notice that the difference here lies in the word used, which is for this one is average, and this one you're talking about instantaneous rate of change of y with respect to x. And why is it instantaneous? Because at this moment here, when delta x gets closer and closer to 0, that means the interval here gets very small and eventually very close to 0. Therefore, you're talking about some sort of instantaneous moment there. Okay, right. Let's move on to example 4.1. And here the example is asking you to find the average of change of the area of a circle with respect to its radius r, as r changes from these two values, and for question 1, and then r changes from 2 to 2.5, r changes from 2 to 2.1. So basically in this part of example 4.1, this is all about finding the change in delta y over delta x. So you're talking about the average of change of a area of a circle with respect to radius. So in this case, area of a circle is y and x is radius. Okay, now the next part is find the instantaneous rate of change when r is equal to 2. So in this example, it is basically asking you to find what is the limit of limiting value when delta x approaches 0. So delta y over delta x, where in this case, of course, delta x here is going to be delta r because the radius is represented here as x, yeah. So our x here is the radius and y here is the area. Okay, let us try and do the first part of this example. So first of all, let us define a function, which is the function is according to what you have seen before. We need to know what is y is equal to fx. This is what we need to know. We need to come up with a function, and in this case our function is a is equal to something related to radius. Okay, the area of a circle is something that is related to radius. That is what we already know. And if you're talking about a circle, the area of a circle is going to be equal to pi r squared. So this is a function, and this function depends on r. Okay, right. Now we are going to find what is the average of change of the area of a circle, which means you are looking to find what is delta a over delta r, and delta r is the change in r. R is change from 2 to 3, so therefore we have 3 minus 2. So that is on the bottom part. Next, on the top part here, we are going to calculate what is the area when r is 3. So when r is 3, the area is pi 9, minus when r is 2, the area is going to be pi times 4, and based on this can be simplified to be 5 pi. Okay, so that's the answer for the first question. Okay, next, the second question is r is now changed from 2 to 2.5. So therefore, in the bottom part here, we have 2.5 minus 2. on the top part here, we need to find what is the area of a circle when r is 2.5 minus 4 pi. And the answer that you will get here is going to be equal to 4.5 pi. So on the third question here, you are asked to find the average of change of the area with respect to the radius when the radius is changed from 2.1 to 2. So sorry, when the radius is changed from 2 to 2.1. So here we have 2.1 minus 2, and the area is going to be pi 2.1 squared minus 4 pi, so that the final answer is 4.1 pi. Okay, so next we are going to find the instantaneous rate of change when r is equal to 2, and this is basically you are going to find what is the limiting value when delta r approaches 0. This is delta a over delta r, and this is just the definition of derivative, which you can obtain easily if you consider finding the derivative of function a with respect to r. So a here is pi r squared over a dr, and here the answer is going to be 2 pi r. Therefore, when r is equal to 2, dA dr, so the derivative of that function is going to be equal to 2 pi 2, and this is just going to be equal to 4 pi. Okay. Now, of course, from what you have seen in chapter 2 or chapter 3, the idea of limit is that as you make this interval smaller and smaller, or as this gets closer and closer to 0, we can see the pattern of values given here, and you can also guess that the instantaneous rate of change is going to be about 4 pi based on the pattern of the values seen in this part. So that is something which you have already seen in chapter 2 or chapter 3. Okay, and like I said earlier, we have an elegant way of finding the derivative or finding the limit of a given function, which is following the rules given in chapter 3, and you'll be able to find the derivative of it quite easily. So the derivative or the instantaneous rate of change when r is equal to 2 is given by the process shown here. Okay, I think that's all for now. Thank you very much for watching.